We've got a formula for annuities. Let's derive it. Let's see where this comes from. So here's what we have in this formula. We have R, capital R, small r, M, and T. So here's what capital R is. Capital R, this is going to be the amount of money that you deposit into your investment at the end of each time period. Say at the end of each month, each week, each year, whatever you decide. You know, we could use like A for amount that you invest or P for the principal that you invest. We're using R because sometimes it's thought of as a rent. And now this lowercase r, that's the annual interest rate. M, that's the number of compoundings per year. Or say we're going to compound, if we're going to invest, say at the end of every month, we would have 12. If we invest at the end of every year, we would just have 1. And T, well, that's the number of years that we're going to invest. Since when we invest, we're going to get a compound interest. I want to write that compound interest formula here. That's what we had in the last section. Just to make it a little bit more simple in the computations, I'm going to replace R over M with I. So this will be I is the interest rate per period, which is what this is. And MT is the number of compoundings all in all, and I'm just going to represent that N for the number of compoundings. So let's start here at, say, the very beginning of our investments, and let's just do this in terms of years, just so I don't have so many dots here. We'll do it in terms of years, say for maybe 5 years. So at the end of the first year, suppose we put in R dollars, right? So right here, I'm going to put in R dollars. Now, this R dollars, that's going to get interest for what? 1, 2, 3, 4 periods. All right, so that N right there will be 4 because it'll compound 4 times. So what we're going to have, I'll try to keep track of it over here like this. Here's how much we're going to have. What is the amount? It's going to be, say, R instead of P, 1 plus I to the 4th. Let's make sure that makes sense, right? We're putting in R dollars. I'm writing R instead of P now. We'll put in R dollars, and that R gets interest for 1, 2, 3, 4 periods, and I is the interest rate. So that's how much money that R, that initial R dollars would be worth after 1, 2, 3, 4 years. Now, again, right in year 2, at the end of year 2, put in another R dollars. Now that R dollars is going to get interest for what? 1, 2, 3 years. So how much will that R dollars be worth at the end of 3 years? Well, let's see. Let's summarize that like this maybe. This is going to be that R dollars and then 1 plus I for 3 years. Then we're going to put, at the end of the 3rd year, we'll put another R dollars in. And that R dollars is going to collect interest for 2 years. So we're going to get, how much is that going to be worth? That's going to be R and then 1 plus the interest for 2 years. Now again, at the end of that, what, 1st, 2nd, 3rd, at the end of the 4th year, we'll put in another R dollars, but that will get interest for just 1 year. So let's see how much that's going to be worth. That's going to be with R, 1 plus I just to the 1st. And in the very last year, we're going to put in another R dollars. But this R dollars, we put it at the end of year 5, it doesn't get any interest at all. So it is worth just R dollars. Or, you know, I could write it like this, and I'll do it just to be consistent. 1 plus I to the 0. Right, look at, I want to do that because look at the exponents. 4, 3, 2, 1, 0. And you know that some quantity, a non-zero quantity to the 0 power is just 1. So this is R times 1, which is just R. We can get the total amount of this investment now just by adding these numbers up, right? So let's do that. So it's going to look like this now. The future value is going to be that top one, R times 1 plus I to the 4th, plus the next one, R times 1 plus I to the 3rd, plus the next one, R times 1 plus I to the 2nd, plus R times 1 plus I to the 1st, plus r times 1 plus I to the 0. That sum here gives us the future value of our investment. So we've got it here, but this is a little bit cumbersome, right? We really don't want to have a formula that has all this stuff in it. So here's what we're going to do. We wanted this investment to go for 5 years. But when I look at what I've got here, I've got a 4, 3, 2, 1, 0. I would like a formula that has the 5 in it. Say if I'm going to go 5 years, I want a formula that has a 5 in it. So I can use this clever little idea. What I'm going to do here is I'm going to multiply both sides by this quantity here, 1 plus I. I'll write it. So it's going to be this. 1 plus I times future value equals 1 plus I times this entire side right here. All right, so I've got that. So do you see what I did here? I started up here. I multiplied this side by 1 plus I. There it is right there. Equals, now 1 plus I times this entire right-hand side, right? Times all of that. Now, by the distributive property, I'm going to distribute this 1 plus I to each one of these terms. So here's where we are. We're at 1 plus I times the future value is equal to, or I get it to the first one, r times, now what do you get here? 1 plus I times 1 plus I to the 4th. So you add the exponent, so we're going to get 1 plus I to the 5th. Then multiplying over here, right, in that second term, you got r, and then 1 plus I times 1 plus I to the 3rd is going to be that r times the 1 plus I to the 4th, plus, now keep on going, right? 1 plus I times the 1 plus I squared, you're going to get r 1 plus I cubed plus r 1 plus I squared plus r times, now what do you get here? 1 plus I times 1 plus I to the 0. So you get a 0 plus 1, so that just now is a 1. 1 plus I. Okay, so hold on here. Here's what we're going to do. I've got two equations. I'm going to take this one right here. How about if I name it double star? And this one up here that I had, I'm going to name that just star so I can keep track of them. And here's what I'm going to do. I'm going to take these and I'm going to write the second equation minus the first equation. So I'll do that here and I'll write it all out so you can see what's happening. But I'm going to take this equation here and subtract, so this minus all this. So here we go. It's going to be this one. It's going to be 1 plus I times FV minus FV. So this is going to be, now I'm going to write the top one, or the second one, I'll write it in a subtraction, like vertically. So I've got the top one, all right, that's this one right here. This one right here, I put it right here. Now minus, right, here's this one is here. Now minus, I'll write the minus sign, minus, okay, the second one. Okay, now it's minus all of this. So it's going to be this one up here, right, FV, and FV is this one. Minus, okay, now here's that other one. This is the FV, right, that's the one up here at the top. So just see what we have. 1 plus IFV, that's this one right here. Minus, minus, FV. Now here's FV, right? That was the one way up here at the top. And I wrote it, I pushed it over a little bit so I could align the terms to make them easier to subtract. Now, I'm going to multiply through here. So what do you get? You get FV plus IFV minus FV, and you can see that the FV minus FV, that's going to go out. And then what are we going to get? Well, I get R, 1 plus I to the 5th minus, okay, 0. There's nothing there, so this is going to be R, 1 plus I to the 5th. And now, watch what happens here. This is nice. You get R times 1 plus I to the 4th minus R times 1 plus I to the 4th. So these cancel. Then you get r, 1 plus I cubed, minus r, 1 plus I cubed. These cancel. Then you get r, 1 plus I squared, minus r1 plus I squared. Those cancel. 1 plus I to the first, minus 1 plus I to the first. Those cancel. So we're just left with 0 minus this term right here. So it's just minus r. Now, I'll write it. 1 plus I to the 0. But that's really, here's what we're left with then, right? We're left with this one. I, FV equals r, 1 plus I to the 5th minus, now, just write this. 1 plus I to the 0, that's just 1. 1 times r is just r. Now, we've almost got it here. I'll do this right here. I got I times FV equals, now look at this. I've got r in both of these terms, so I'm going to factor that out. So I get r, factor it out. I get 1 plus I to the 5th minus 1. And then I can get FV right here just by dividing by I. So I'm going to get this. I get FV equals R, 1 plus I to the 5th minus 1, all over I. And now one more step. What I'm going to do is I'm going to replace the I with our R over M. R over M. So we will have this. The future value is equal to R, and then what do we have? 1 plus I, but I'll write that R over M. Now instead of to the 5th, this is just going to be, instead of 5, well, let's just do it here. Minus 1 divided by R over M. Now we can make this more general because what we did was we did this just for 5 periods. If we did it for 6, this would be a 6. If I did it for 10, this would be a 10. If I do it for, say, n number of times, then this is going to be an n. So here's our formula then. Future value is R times the quantity 1 plus R over M. Now instead of 5, that could be an n. But remember n, that's the number of number of total payments. That's MT minus 1 all over R over M. And there's the derivation.